Here are the notes for section 6.5, which is graphing parabolas, but now we're adding one more detail, which is finding the vertex. So this little box tells us the things that we need to know, and we'll reference those as we're going through this outline and then the one example. So when you have y equals ax squared plus bx plus c, if a is positive, the parabola opens up. If a is negative, the parabola opens down, so that's the coefficient on x squared. C, the constant term, is the y-intercept. And to find the x-coordinate of the vertex, you take negative b over 2a. So that would be negative b from here over 2 times a from here, and that's the x-coordinate of the vertex. And to find the y-coordinate, you plug in the x-coordinate. So this is an outline. If we have ax squared plus bx plus c, how do we know if it opens up and down? If a is positive, it opens up. If a is negative, it opens down. The vertex, you do x equals negative b over 2a, again, b from here, a from there. And to find the y-coordinate, you plug in the x-coordinate. How do you find the y-intercept? The y-intercept is the c value from there. The axis of symmetry. So if you have a parabola, it's symmetrical. The axis of symmetry is a vertical line that goes through the vertex. So what is the equation of that line? Well, it's x equals a number. So x equals a number, that's a vertical line. So that would be negative b over 2a. And notice that you found that before, so you don't have to do that again. And then we're going to pick the two x values and plug in. And that will give us 2 points, like one over here and one over there, so we can connect them and make our nice round parabola. But we're going to pick them carefully so that we don't end up going way off the graph. So pick an x close to the x coordinate of the vertex. And one on the left and one on the right of the vertex, and then connect the dots. All right, so we're going to do one example here. Now let's do an example. So here we have a new function. It's quadratic. So we're going to start by deciding if it opens up or down. So since a is negative 2 is negative, it opens down. So it will look like that. To find the vertex, we first find the x-coordinate, which would be negative b over 2a. So negative b, which is negative 4, over 2 times a, which is negative 2. Negative 4 is positive 4. 2 times negative 2 is negative 4, so that's negative 1. And then to find the y-coordinate, we plug in the negative 1 into the equation. So y would be negative 2 times negative 1 squared minus 4 times negative 1 plus 5. Negative 1 squared is positive 1 times negative 2 is negative 2. Negative 4 times negative 1 is positive 4 minus 5. Negative 2 plus 4 is 2. Oops, this was a plus 5. So 2 plus 5 is 7. So the vertex is the point negative 1, 7. The y-intercept is always the c value. So the y-intercept is going to be c, which is 5. The axis of symmetry is a vertical line. So that would be the equation x equals negative b over 2a, which we already did, so we know that that's negative 1. The axis of symmetry always goes through the vertex. And then we're going to pick two x values. Remember that x values have to be close to the vertex. So the x has to be close to -1 and plug them in. So what's to the left of -1 but close? Well, that would be -2. So let's plug in x equals -2. And that would give us y equals -2 times -2 squared minus 4 times -2 plus 5. -2 squared is 4. 4 times -2 is -8. -4 times -2 is +8 plus 5. -8 plus 8 is 0 plus 5 is 5. So that's the point -2, 5. So that's 1 point. So -2 was close to -1, but to the left. So now what's to the right of -1 but close? So there's more than one choice, but the next integer to the right of -1 is 0. So let's plug in x equals 0, which it turns out we already have this, but we'll do it for practice. -2 times 0 squared minus 4 times 0 plus 5. So that'd be 0 plus 0 plus 5, which is 5. So that's the 0.05. So that happens to be the y-intercept. We don't always end up with the y-intercept as this one as well, but that's fine. Now we're ready to connect the dots and graph and get our parabola. So let's start with the vertex, which is at -1, 7. 1, 2, 3, 4, 5, 6, 7. And then the y-intercept is 5. 1, 2, 3, 4, 5. And then the axis of symmetry is at x equals -1. So that's this. And -2, 5 is here. And 0, 5 is the same one. And now I'm ready to connect them, making sure that the vertex is the place where they turn around. And notice it opens down, which is what I expected. So we're done.